Hey, what's up guys? This video is for section A2, which is multiplying a polynomial by a monomial. So first, let's understand what we are multiplying. So let's go and look at the vocabulary that you guys see on the top. First, polynomial is when you have poly, many terms, and you're going to multiply that polynomial by a monomial, and the root word mono means one. So you guys are going to have 2 terms binomial, 3 terms trinomial, 4 terms quadrinomial, and you're going to multiply by 1 term monomial. So how do you multiply a polynomial by a monomial? Well, when you multiply polynomials, first you multiply the coefficients in front of the variables, then you keep the variables and add the exponents of the same variables, the corresponding variables. So what I'm trying to say here is when you guys look at these 2 polynomials, and notice that they're not really poly many, they are monomials. You have 1 term, but you want to multiply 3x y times negative 5x squared y cubed. How do I know I'm multiplying? Well, first of all, in between the y and the parentheses, there's no plus or minus in right here in between, so that is multiplication. You have parentheses and you're going to multiply. Now this one here is also a monomial because in between the 5 and the x, there's no plus and a minus. In between the variables here, there's no plus and a minus. So you guys are going to multiply the coefficients. So I'm going to take the 3 and the negative 5. So I'm going to write that down here, 3 times a negative 5. Then I'm going to multiply the variables. So I'm looking at the x's. I do have an x to the first power right here, and I have an x to the second power over here. So I'm going to multiply those 2. I'm going to have x times x squared. So I put those together. Now you guys are going to multiply everything here. That's why I'm going to put a times in between the x and the negative 5. But now you guys move on to the y's. And for the y's, you guys have a y outside with an exponent of 1, and you guys have a y inside with an exponent of 3. So you're going to multiply y times y to the 3rd power. Now remember, we are multiplying everything, so I'm going to multiply the x squared and the y in between. So I'm going to have a multiplication symbol there. And now I'm just going to multiply the coefficients, the numbers. So 3 times negative 5, that's negative 15. I'm going to multiply the x's. X times x squared, that's going to be x to the 3rd power. Notice that I am adding the exponents. Remember, this x has an exponent of 1. So 1 plus 2 is 3. And then I multiply the y's, and I have a y to the 4th power because I am going to add the exponents. Here's the 1. Let me put the 1 there so you guys can see the invisible 1. And I'm going to add 3 to the 1. 1 plus 3 is 4. So this is going back to the properties of exponents. When you guys have the same base, the same variable, you add, and you're multiplying the bases, you add the exponents. So my answer is negative 15x to the 3rd, y to the 4th. I don't need that times symbol in between the 15 and the x and the times symbol between the x and the y, but it is there. It's an invisible times, so you are multiplying those terms, but it is a monomial because it's only 1 term. So let's try another one here. You guys have the same thing. We have a monomial outside negative 7x to the 4th times a monomial 6xy to the 3rd. It is a monomial because there's no plus or minus in between the variables and the numbers. Right here in between, there's no plus or minus. We do have a negative here, but that's the negative 7. So that's not part of the monomial or the polynomial. The one you guys look at is the one in between the numbers and the variables. So a monomial times a monomial. So same thing as the one we did right now. You multiply the numbers here. So we have negative 7 times 6. Then I am going to multiply the x's. So I have an x to the 4th times an x. And I'm going to look at the y's. Now outside of the parentheses, I don't have a y, but I do have a y to the 3rd inside. So all we do, we bring down the y to the 3rd. And we don't have a y to multiply here, but I'm just going to bring down the y to the 3rd. So now you guys multiply the coefficients. Negative 7 times 6, that's negative 42. I'm going to multiply the x's. So I keep the base x. I add the exponents. So x to the 4 times x to the first power, 4 plus 1 is 5. So we have x to the 5th. And you keep the y to the 3rd power because we don't have another y to add an exponent to that 3. So my answer is negative 42 x to the 5th y to the 3rd. So that's the idea when you multiply polynomials. You guys multiply the coefficients and keep the same variables and add the exponents of the same variables, the corresponding variables. So now we're going to just expand the idea, the concept. We're going to start multiplying a monomial times a binomial. Bi means 2, so we have 2 terms. A monomial times a trinomial, and we have something else to show you here in the video. So let's look at these examples here. So first of all, let's multiply the one on the left side. You want to say, and notice it says simplify. It doesn't say add or multiply or subtract. Simplify means you guys need to know, understand what operation you must do. So I'm looking at the 2 outside, and I have a parenthesis, nothing in between, and I have a binomial 7x plus 1 inside. This is multiplication. You don't have anything in between the number and the parentheses, so you multiply. So one way to multiply a monomial, 2 is just one number. You are going to distribute. You are going to multiply. So that's the distributive property. You are going to multiply the 2 times the 7x. So the 2 and the 7, you multiply the numbers. And I'm not going to write down the numbers again, but you just do some mental math. You multiply 2 times 7, and that's 14. X, I don't have an x outside with the 2, so I just keep the same x inside of the parentheses, so that's 14x. And then I multiply the 2 times the next number, 2 times 1, and it is a positive 2. So my answer is a binomial, 14x plus 2. Now, if you guys have variables outside and inside, same concept I showed you guys on the previous slide here, you are going to multiply the coefficients of the terms, you keep the variables, and you add the exponents of the same variables. So I have a 3x outside of the parentheses, and I will multiply by a 2x squared. So first, let's multiply the numbers. 3, the coefficients. 3 times 2, that's going to be 6. And notice I'm doing mental math. That's what you can do. You don't have to write down the numbers. Again, you just do that mental math. And now you multiply the x times the x squared. Now the x outside of the parentheses, it has an invisible 1 exponent. So remember, you guys are going to keep the x, keep the variable, and add the exponents of the variables. So 1 plus 2, that's going to be 3. So we have 6x to the 3rd power. Then you guys are going to multiply the 3x times the next term. So 3x times x cubed. Notice the x cubed, remember it has an invisible 1 coefficient. So you multiply the numbers, 3 times 1, that's going to be 3, and it is positive because they're both positive. So we have a 3. And you multiply x to the 1st power times x to the 3rd power. Since you're multiplying, you add the exponents. So we're going to have x to the 4th power. So that is my answer. So what about if you guys have 2 different variables? We have a p and a q outside of the parentheses. It is a monomial, 7pq, and we have a trinomial inside of the parentheses. Well, you should do the same thing. You guys are going to multiply this outside times the 1 inside. So look at the coefficients first. 3 times 7, that's going to be 21. I look at the p's. I have a p, and let me put the exponent of 1 here. And the p inside has a square. So p to the 1st power times p squared. You guys keep the variable p, and you add the exponents. Now the next variable, which is the q next to the p, this q has an invisible 1 exponent. So I'm going to put a 1 right here on the top. And inside of the parentheses, there is no q. So what that means, you just bring down the q next to the p cube. So I'm going to have a q right here. And then you guys move on to the next one. So the next one, you're going to multiply 3pq times a negative pq. Now remember that the negative pq has an invisible 1 coefficient, the number in front of the p. So you multiply the 3 times the negative 1, and that's going to be negative 3. you guys do have a p outside times a p inside, and this one also has an invisible 1 exponent. So it's going to be p squared because you guys add the exponents of the p's. But we also have a q outside with an exponent of 1 and a q inside with an exponent of 1 as well. It is an invisible 1. So you guys add the exponents and we're going to have q squared. And finally, you guys move on to the last term. So you multiply the 3pq times the 2q. So first you multiply the numbers, 3 times the 2, positive 2, that's going to be positive 6. There's a p outside, but we don't have a p inside to multiply or add the exponents. So you're just going to have the p to the first power. Remember, this p has a first power, so you just bring it down. And q times q, the one inside, you guys will have a q squared because you guys have an exponent of 1 here inside of the parentheses. So you add the exponents, the q1 exponent, q1 exponent, 1 plus 1 is 2. So it's going to be q squared. Now these terms right here are not like terms because every variable has a different exponent. We have a pq, p squared, a p. We have a q, we have a q squared, and a q squared. Now you might be thinking, well, what about these two in red? Are those like terms? Well, they're not, because even though the q's have the same exponent, look at the one next to it. The p do not have the same exponent. So in order to add or combine these two terms, the p's and the q's must have the same exponents. So this p has a square, this q has a squared, this p has a 1, this q has a square. So they're not the same. So my answer is right here. Okay, so let's try another one where you guys have two different variables and you guys have a negative outside. Notice it says here simplified. So you are going to multiply because you guys have a monomial times a trinomial. So I am going to multiply this monomial here, negative 5xy times the x squared. So remember, the x squared has an invisible 1. So negative 5 times the 1, that's going to be negative 5. You guys do have an x outside times an x squared inside. Remember, the x outside has an invisible 1. So x to the invisible 1 exponent times x squared. That's going to be x to the third. You guys do have a y outside, but we don't have a y inside. So I'm going to have a y by itself because I'm not going to add anything to this y, the exponents, because we don't have a y inside. So now you guys move on to the next one. So I'm going to take the negative 5 times the negative 2xy. So I do have the coefficients. The negative 5, you multiply by the negative 2. And we have a positive 10, negative 5 times negative 2. And I do have an x to the first power times an x to the first power inside of the parentheses. So that's going to be x squared. Now we do have a y outside, a y inside. So when you guys add the exponents, this y outside has an invisible 1 exponent, the one inside has an invisible 1. That's going to be a y squared. Then you guys move on to the last one. So multiply negative 5 times the negative 11y squared. So negative 5 times negative 11, that's going to be positive 55. We do have an x outside, but we don't have an x inside, so we just keep the x, the one outside. And when you multiply y times the y squared, add the exponents, and that's going to be y to the third power. So we do have a trinomial as the answer. None of the variables in the terms have the same exponents, so x to the third y, x squared, x, y cubed. Nope, they're not the same terms, so we have the answer. Now let's look at one where you guys have an actual fraction and you guys multiply the monomial. You guys can have that in a monomial. You can have a fraction with the regular number on the bottom here, and then you guys multiply. If the variable is under the fraction, that's when we say it's not a polynomial. But right now, this one is a monomial. So it's okay to multiply. I'm going to take all of this right here, and I'm going to multiply by the first term. So to multiply fractions, well, first of all, you look at the signs. A negative times a negative, that's going to be a positive. But you guys will multiply the top number times the inside. So 2 times the 9. And you keep the denominator. So that's going to be positive 18 over 3. Now when you guys multiply the n squared times the n squared, you guys add the exponents. So that's going to be n to the 4th power. Then you guys move on to the next one. You multiply the negative 2 over 3 times the n squared. That's going to be a negative because we do have a negative times a positive. That's going to be a negative. 2 times the 3, that's going to be 6, and you keep the denominator. And when you multiply the n squared times the n, this one has an invisible 1 exponent. So 1 plus 2, that's going to be n to the 3rd. And the last one, you multiply negative 2 over 3 times 6. Well, we have a negative times a positive. That's going to be a negative. A 2, the top number, times the inside, times 6. That's going to be 12. Keep the denominator. And we do have an n squared outside, but we don't have an n inside. So you keep the same variable with the same exponent. Now you guys are going to reduce or simplify the fractions. So we have these fractions here, you guys can reduce. So I'm going to have 9, no, not 9, sorry. It's going to be 6n to the 4th, 18 divided by 3, minus 2n cubed, 6 divided by 3, minus 4, 12 divided by 3, and we have the n squared. Now notice that we do have the trinomial in standard form because we have the highest exponent first, and then you guys go down. 4, 3, 2, and that is my answer. Now let's go ahead and multiply when you have more than one polynomial or more than one parenthesis and you're trying to find the product. Now once again, it says simplify, but you have to understand what you guys need to do. So here we do have a monomial times, notice there's nothing in between the parentheses and the p, so that's multiplication, times a binomial. So we have two terms. So we're going to multiply 2p times negative p squared plus 5p. Then we are going to have minus 5 times 2p squared plus 20. So you're also going to multiply the 5 times the binomial. So you're going to distribute, and after you multiply, you're going to look for like terms. You combine like terms. So this monomial right here, we have a 2p. First you multiply by negative 4p squared. So 2 times negative 4, that's negative 8. A p times a p squared, that's going to be p to the 3rd power because this one has an invisible 1 exponent plus 2, that's 3. You add the exponents when you multiply the same basis. And then you multiply 2p times the 5p, that's going to be positive 10. You multiply the numbers, 2 times 5 is 10. And we have a p squared. When you multiply p to the 1st power times p to the 1st power, you add the exponents 1 plus 1, so it's p squared. Then you guys are going to multiply this number here, the negative 5. Notice it's a minus 5. You keep the sign with the number, negative 5, and you multiply by 2p. So that's going to be negative 10. You multiply the numbers, p squared. You don't have a p outside the parentheses, so you just keep the same p squared inside. Then you multiply negative 5 times 20, positive 20. That's going to be negative 100. Now we do have like terms. Notice what's in between right here and these two right here. A positive p squared minus a 10p squared. 10p squared minus 10p squared, 0. They cancel. So what we have left is the negative 8p cubed. We don't have another cube, so you bring it down. Minus 100. We don't have another constant, so that is my answer. You guys multiply what's outside to what's inside, and then you guys combine like terms. All right, now this one's a little bit different because you guys do have a monomial times binomial, but this one here is not inside of the parentheses. So you guys are going to multiply this monomial times what's inside, but not the one outside over here. You guys keep that the same as it is. So first, let's multiply the 3f times the 5f. That's going to be 15. F times f is f squared. 3f times negative 3. That's going to be negative 9f. And now you guys are going to bring down the minus 2f. Minus 2f, because you're not going to multiply this one by 3f. It's not inside of the parentheses. So you just bring it down. Now you guys are going to combine like terms. We do have like terms. if you look at these two terms, negative 9f and minus 2f, those have the same variables. Look at the variables f and an f, and the f's have the same exponents. This one has a squared, so we don't have another f squared, so we just bring that one down, 15f squared, and when you combine negative 9f minus 2f, negative 9 minus 2, you just combine the numbers, that's going to be negative 11. You add the numbers because they have the same sign, and you keep the sign. So negative 11 and keep the variable f. Now notice what happened. I don't write a squared because I don't add the exponents. When you guys combine like terms, you keep the same variable with the same exponent. So my answer is this. Now this one here is just a little bit challenging to get you guys going into multiplying and combining like terms. You really have to understand how to multiply those monomials. So you notice that we do have a 2j times a trinomial, so you're going to multiply all of that by 2j minus, and we do have a trinomial, so this minus you're going to have to distribute because it's outside of the parentheses. So you multiply everything outside of the parentheses, you multiply by what's inside. So we do have a plus 3k times negative 2k plus 3. So let's start from the beginning. You guys are going to multiply the 2j times the 7j squared k squared. So first you multiply the numbers. 2 times 7, that's 14. The j times the j squared, that's going to be a j cubed. You add the exponents. So 1 plus 2 is 3. And we don't have a k outside, just a k squared inside. So you bring that one down, and we have a k squared. Then you move on to the next one. 2j times j k squared. Well, this one has a 1 here. You multiply the numbers. 2 times 1 is 2. J times j is j squared. And you keep the k squared. So we do have a j and a j. That's j squared. And keep the k squared. Now you guys multiply this one times the next one. So 2j times 5k, that's going to be positive 10. 2 times 5 is 10. jk. Those are not the same terms, not the same variables, so you do not add the exponents. But now, you guys are going to distribute the negative to the parentheses. So negative times a negative 2, and remember that it is an invisible 1 here, so it's a negative 1 times a negative 2. That's going to be a positive 2. J squared k squared. There's no variable outside of the parentheses right here, so you don't add the exponents. And now you guys multiply the next one. Negative 1 times positive 2, that's negative 2. And we have a k squared. And the next one, negative 1 times positive 3, that's negative 3 with the j. And now you guys are going to multiply the last one here outside of the parentheses times the one inside. So negative positive 3k times a negative 2k, that's going to be a negative 6k squared. A k times a k is a k squared. And you multiply the next one, 3k times 3, that's going to be positive 9k. We don't have a k inside of the parentheses, so you don't add the exponents to the k, you just bring it down. Now you guys need to look for like terms. And you always want to start with the variables that have the highest exponent. So I'm looking at the j's. There's a lot of j's right here, j, and there's another j over here. With the one with the highest exponent is cube. So I'm going to look for another term that has a j cubed and a k squared, because that's going to be a like term with this term right here. So this one, nope, no, not a j cubed, nope. So this is the only one we had that has a j cubed k squared. So this term, we're going to bring it down. 14j cubed k squared. Now I'm going to move on to the j squared. So I do have a j squared here. So notice I do have a j squared k squared, and I'm looking at another j squared k squared. This one. This one here, k squared, doesn't have a j squared, so this is not a like term with a j squared and k squared. But we can combine this one plus 2j squared k squared and this one plus 2j squared k squared. First, you add the exponents because you're combining 2 plus 2. That's going to be 4 positive, and you keep the same variable with the same exponents. You're not multiplying those two terms, you're just combining, you're adding. So we're going to have a 4j squared k squared. Then you guys go down to the j's. So I'm looking at the j's. Here's a j with the k. I'm looking for another j with the k. Now these ones only have one variable. So I'm looking for the one that has two variables, jk, and that's the only one. So this one here is by itself. You bring it down, plus 10jk. Now I'm going to move on to the one that has only one variable. So let's start with the j. You always want alphabetical order. So the minus 3j, I don't have another term with the j, just by itself. So you just bring that one down, minus 3j. And we do have a negative 2k squared and a minus 6k squared. Those are like terms because they have the same variable, just a k squared with the same exponent. So negative 2 minus 6, that's going to be negative 8k squared. And the last one, we have a 9k. I don't have another one with the k, so we just bring it down. So all of this right here is your answer. None of the terms are like terms on this one because every term has a different exponent with the variable. J cubed k squared, j squared k squared. These are not like terms because the j's are not the same. Jk, they don't have an exponent of 2 or 3, so not the same. J, k squared, and the k, these are not the same term because this one doesn't have a square. So that's my answer for this example. You just distribute and you guys combine like terms. All right, so now we're going to start solving equations when you multiply a monomial times a polynomial and you want to isolate the variable. So these two examples here is solving. So you do have an equal sign in the middle. You guys want to get the variable by itself. So you're going to have, for example, here, there's a t. So you need a t equals a number as your answer. And then you guys have to actually simplify the equations. So here, you guys are going to multiply. We do have a t outside times the one inside. So you distribute, you multiply. That's going to be 2t squared. A t times a t is a t squared. You multiply times the next one. T times 3, that's going to be plus 3t. And you bring down the plus 20. You are not going to multiply by t because it's not inside of the parentheses. On the right side, now remember that the equal sign is kind of like a wall right here. It's the border. So now you guys do the right side of the equation. I'm going to distribute this one to the parentheses. 2t times t, that's going to be 2t squared. And 2t times 3, negative 3, minus 6t. There's a positive 2 outside. There's a minus 3. That's a negative 3. It's negative 6t. Okay, so now you guys want to get the variables on one side. So I do have a t squares. I have a t on each side. So you always want to start with the highest exponent. So we have a t squared. So in order to get rid of this 2t squared, I'm going to do the opposite. That's solving equations. You guys need to do the opposite. And whatever you do to one side of the equation, you're going to do to the other side. So I am going to subtract 2t squared. And I'm going to subtract 2t squared on the left side of the border. Here's the line. So here's the left side. Now notice what I do. I always align the terms that have the same variables with the same exponents. So t squared with the t squared with the t squared. And guess what happens? Cancels, cancels. So all we have left is a 3t plus a 20. Let me bring down the equal sign, a negative 6t. All right, we're almost there. Now we need to solve for t. We don't have a t squared anymore, but we do have a t. So I'm looking at the t's, and the lowest t variable is the negative 6. Negative 6 is lower than positive 3. So I'm going to do the opposite. I'm going to add 6t. That's the opposite of negative 6t. So I'm going to add 6t over here. So I'm going to have a 9t, 3t plus 6t is 9t plus 20 equals, and this right here turns into 0. Negative 6t plus 6t, they cancel. So I'm going to put a 0. Now you guys solve like a regular linear equation. You guys are going to subtract 20 from both sides. So that cancels. So we're going to have 9t equals negative 20. You guys are going to divide by 9. So this turns into 1. and we have t by itself equals, and negative 20 over 9 cannot simplify, do not turn it into a mixed number. We're just going to keep it as an improper fraction, negative 20 over 9. So, same idea as solving equations. You just need to multiply, distribute, multiply the variables, and then solve for t. So let's try another one here. You guys do have another equation. So outside we don't have a variable, but we do have a number. So I'm going to multiply the 8 times the 3b. So it's going to be 24b. The 8 times the 1, that's going to be positive 8. I'm going to put the wall or the border right here. And on the right side, I'm going to multiply the 4 times the b. That's 4b. And the 4 times the 3, that's going to be 12. Now, this minus 9 is not inside of the parentheses, so I'm just going to bring it down. Do not multiply by 4. You guys can combine like terms, because on the right side, if you look at the constants, the numbers, right here, we have a 12 and a minus 9. So let me bring down the equal sign right here. So I'm going to have a 4b on the right side, and 12 minus 9 is 3, positive 3. On the left side, I don't have like terms. On this side, 24b and 8 are not like terms. So I'm just going to bring that one down, 24b plus 8. Now I'm going to solve for b. So the lowest b is the 4. I'm going to do the opposite, subtract 4 from both sides. So that's going to be 20b plus 8 equals, this cancels, 3. You guys subtract 8 from both sides. That's gone. 20b equals negative 5. You guys divide by 20. And whatever you do to one side, you have to do it to the other side. So that turns into 1. So we don't need the 1, just a b equals. And yes, you can reduce the fraction. You can divide both sides by 5, the top and the bottom. So we have a negative 1 on the top, 5, negative 5 divided by 5 is 1. And on the bottom, we have a 4. 20 divided by 5 is 4. So my answer, B, is negative 1 over 4. And the last example, guys, for this video is kind of like a word problem, but this is where you guys need to apply what you learn from transforming or translating a word problem into math. You have to model with mathematics, and then you guys have to either simplify an expression or maybe solve an equation, or you guys need to write down your expression. So let's go ahead and read what it says here. It's about number theory. Let x be an integer. And it says, what is the product of twice the integer added to 3 times the next consecutive integer? So first, we need to understand what we need. It says here that we do have x. Let x be an integer. Integer is a negative number, positive number, not fractions, not decimals. It's just a number with a negative or a positive. You can say a whole number, but it's also negative and positive. Now, what we need to know is what we need to translate. What do we need to write down? So it says here that you guys have twice the integer. So let's start with that. Twice means you multiply something by 2. So you're going to multiply 2 times the integer. So the integer, remember, that's x. So I'm going to have 2 times x or 2x. That's how we start. Then it says here added. So we have twice the integer added. So I'm going to put the plus right here. And we have 3 times, and I'm going to highlight that so you guys remember we are multiplying, 3 times the next consecutive integer. So let me explain what that is first of all. 3 times. Notice I'm using parentheses because parentheses is the same thing as multiplication. 3 times something. Now for the next consecutive integer. In order to find the next consecutive integer, it doesn't matter what number you guys think of. The next consecutive is going to be 1 more than the number you guys are thinking about. So I'll give you guys an example. If I start with the number 11, the next consecutive integer is 12. That's 1 more than 11. If you guys think about the number 7, the next consecutive integer will be 8, and it is 1 more than 7. So how do you translate that into algebra? You guys will take the number that we don't know what it is, x, and we're going to add 1 to it. So that's going to be 1 more than the number you guys are thinking about. So this next consecutive integer is going to go inside of the parentheses. 3 times x plus 1. Now remember that 3 is right here. So you have 3 times the next consecutive integer. You guys are going to simplify. The 2x here is not inside of the parentheses. So you're just going to bring that one down. And I will multiply this positive 3 times the x. So that's going to be positive 3x. And positive 3 times the 1. And that's positive 1. That's going to be positive 3. I'm going to add like terms, the 2x and the 3x. And we have a 5x plus a 3. Now notice the question. It says, what is the product of twice the integer added to 3 times the next consecutive integer? They're not asking for the integer. They're not saying solve for x. So we are not going to write an equation. We are not solving for x. My answer is this algebraic expression, and it is a polynomial, 2 terms, binomial. We have 5x plus 3. All right, guys, so this concludes my video. I want you guys to click subscribe if you guys like my channel, and also you can like the videos whenever you want, and make sure you guys practice, and I'll see you guys later.